In today's class, we are going to discuss the relationship between beta and gamma functions. Relationship between beta and gamma functions. That is beta of m comma n equal to gamma of m into gamma of n divided by gamma of m plus n. In this, we could have analyzed it. What are the requisites? We have the alternate forms. We know that the beta alternate form, gamma definition and all. So let me consider the beta of m comma n is twice of integral 0 to pi by 2 sine to the power of 2m minus 1 theta cos to the power of 2n minus 1 theta with respect to theta. Let me call this as equation number 1. Similarly, gamma of n definition is twice e to the power of minus x square x to the power of 2 x to the power of 2n minus 1 with respect to x. So let me call this as equation number 2. Now in the gamma of n, we taken the parameter as a x. For gamma m, let me take the parameter as a y. So twice of integral 0 to infinity e to the power of minus y square y to the power of 2 instead of n, we have your m. Okay. So 2m minus 1 with respect to y. So let me call this as equation number 3. Same way, let me replace m by m plus n. And to know the difference of the integrals, we are using the parameter as r for gamma of m plus n. Okay. So twice of integral 0 to infinity e to the power of minus r square. We are using the parameter as r here into r to the power of twice of, see, instead of m we have m plus n, so m plus n minus 1 dr. So let me call this as equation number 4. Okay, so you have to take the equation number 2 and 3 and find out the product, that is gamma of m into gamma of n. So this is equal to, we could have write 4 times of double integral. So double integral 0 to infinity, 0 to infinity e to the power of, if the base is same then power can be added by using the law of indices. So we can write it as, after taking minus as a common, we can write x square plus y square x to the power of 2n minus 1 y to the power of what, 2m minus 1 dx dy. So let me call this as equation number 5. So now we have to evaluate the what, right hand side part of this equation into the changing into the polar. Okay, so while changing into the polar, I'll write below, let us evaluate the right hand side, the right hand side part by changing into polars. So what are the polar coordinates we have? X is equal to what? R cos theta. The relationship between the Cartesian coordinate to the polar coordinates it is x is equal to r cos theta and y equal to r sin theta. X and y are called the Cartesian coordinates, r and theta are called the polar coordinates. So you can take the square on both sides, and even in y equal to r sin theta also you have to square on both sides. So while you are squaring on both sides, you are getting x square equal to what? R square into cos square theta, and here it is y square equal to r square sin square theta. Okay, add these two equations, and we are getting as x square plus y square equal to r square of cos square theta plus sin square theta. So cos square theta plus sin square theta value is what? 1. Okay. So we can write it as x square plus y square equal to r square. And also we know that dx into dy when we are writing into the polars, so it will be the r into dr into d theta. So now r varies from 0 to infinity and theta varies from 0 to pi by 2. Okay. So now the equation 5 will becomes gamma of m into gamma of n equal to 4 times of integral r equal to 0 to infinity integral theta equal to 0 to pi by 2 e to the power of minus r square. And what is the x we have? X is r cos theta. So let me substitute r cos theta whole to the power of 2n minus 1, and y is r sin theta whole to the power of 2m minus 1. So dx dy is r into dr d theta. Okay. So now you could have split this integral, and we are getting as we will make this better. First, let me simplify this r power and r to the power of 2n minus 1, r to the power of 2m minus 1, and here one more r we have. So if the base is same, then power can be added by using the laws of indices. Okay. So let me write this 4 into what integral r equal to 0 to infinity and integral theta equal to what 0 to pi by 2 and e to the power of minus r square. So here we can split uh, the law of indices which we have a into b whole to the power of n means you will write a to the power of n into b to the power of n by using the what law of indices, right? In the same concept we are going to adopt in this respective terms. So here r to the power of 2n minus 1, here r to the power of 2m minus 1, and here we have r power as what 1. So then if the base is same, so we can add the power, and also simultaneously you can take the 2 as a common, and we were getting as a 2m plus 2n, and here 1 will be get cancelled and we are getting as minus 1. Yes. Okay, sine to the power of sine to the power of 2m minus 1 theta cos to the power of 2n minus 1 theta dr d theta. Okay. Now let we group the terms which is consisting the theta and which terms consisting the r. So twice of integral r equal to 0 to infinity, we have here e to the power of minus r square and r to the power of 2m plus 2n minus 1. Shall we write this as 2 of m plus n minus 1 into dr? Okay. And another term, I'm going to write it down. Integral, twice of integral theta equal to 0 to pi by 2 sine to the power of 2m minus 1 theta cos to the power of 2n minus 1 theta d theta. Okay. So by using the equation number 1 and also we can observe that equation number 4. Okay. So we can write for right hand side part what we have in the equation number 4 as what? Gamma of m plus n. And another one, the equation number 1, you can observe this term. In this term, in the right hand side part, of the equation number 1, we have representing this integral as beta of m comma n. Okay, fine. So this is what beta of m comma n. Okay, left hand side we have gamma of m into gamma of n. So you cross multiply this, we are getting as beta of m comma n as gamma of m into gamma of n divided by gamma of m plus